Warning: potassium hydroxide and chromium nitrate are corrosive. Potassium nitrate may ignite when mixed with organic materials. Fire safety protocols should be in place, and proper PPE should be worn when handling the chemicals. Hi guys, here is MH. This is my second video in my green chemistry series, and today we'll be making two useful chemicals, potassium nitrate and chromium hydroxide, from potassium hydroxide and chromium nitrate via a salt metathesis reaction. Now, chromium nitrate monohydrate is a very interesting chemical due to the fact that it decomposes at around 80 degrees C to produce water, nitric acid, and chromium hydroxide. I'll cover this reaction in my next video immediately, but besides nitric acid, I also want some potassium nitrate for making sugar rockets, so I came up with this salt metathesis route that avoids using a distillation apparatus and is relatively simple. Anyways, we'll start the preparation now. I weighed out around 84 grams of potassium hydroxide in a plastic bottle and dissolved it in around 100 ml of water. I then weighed out 200 grams of chromium nitrate monohydrate, which is a beautiful purple crystal. 150 ml of water was then added to it, and the purple color is replaced by the dark green color of hydrated chromium ions. I heated the chromium nitrate solution slightly to make sure all solid dissolves, and finally combined the two solutions. A large amount of dark mud precipitated, which is hydrated chromium oxide, along with a little bit of basic chromium nitrate and carbonate. I shook the floss strongly and a lot more precipitate appeared while turning from dark green to blue. I checked the pH and it was around 7, which was perfect. After boiling the solution to decompose the hydrated chromium oxide and hopefully making the filtration easier later, the mixture was transferred to a large beaker with a lot of pain. I didn't have time left to filter it that day, so I left the beaker on the table, and by next morning, a lot of beautiful needle-like crystals of potassium nitrate appeared. I quickly boiled the mixture again and passed it through a filter. The filtrate was crystal clear, which was an awesome sign that everything reacted fully. When it cooled a bit, the beautiful crystals of potassium nitrate formed again, and it was just really fascinating to look at. After washing the precipitate with a bunch of extra water, it was then transferred into a petri dish to dry. There are still some precipitate stuck in the funnel, and I moved it into the dish as well. However, I was very disappointed after the precipitate dried 1 week later. A bunch of potassium nitrate was still stuck in the chromium hydroxide. Now, I have to pay the price for being lazy and using a simple filter instead of my vacuum filtration apparatus. I then tried to recover some potassium nitrate by boiling the chromium hydroxide in some water, and it splashed all over the place, which was really annoying. I filtered the mixture, and after the filtrate cooled down, some beautiful crystals crashed out. I filtered it off and dried it on the hot plate, and the recovered yield is about 18 grams. With a total yield of 68 grams, I wasn't even close to the theoretical 150, but I'll call it a day and do my experiments with this amount of potassium nitrate. It'll mainly be used in making sugar-fueled rockets and organic nitrations, so remember to check the videos about them later.